Okay, welcome to exercise 1D. It's method of differences. Notice a rather bizarre photo. It's actually from parts of the Caribbean, and we've got Captain Jack, whatever his name is, holding a telescope, and that's the reason for this being here. We're going to look at things called telescoping sums. So it's not just a random photo, honest. First of all, let's have a go at this starter exercise. It says do 2 cubed minus 1 cubed. Well, I know 2 cubed is 8, and 1 cubed is 1. And the temptation is to attack this like this way. So I shall carry on doing it. 3 cubed is 27, minus 2 cubed is 8, plus 4 cubed is 64, minus 3 cubed is 27. Know your cube numbers. This is a lot quicker. We won't have to work these out. 5 cubed is 125, minus 64. And then I can look at each sum separately. And that looks like 19, and that looks like 37, and that looks like 61. So if I add all those up, what do I get? I get 61 and 19 makes 80, plus another 44, so 1, 2, 4. I say temptation is to do that, because actually there's a trick. Look, I have got here 2 cubed, and then I take away 2 cubed. So there you go. And then I've got a 3 cubed, but then I take away 3 cubed. So there you go. I've got a plus 4 cubed, I take away 4 cubed. So in actual fact, there's only 2 things left. And the 2 things are those. So really it's plus 5 cubed, which is 125, minus 1 cubed, which is 1. So the answer's got to be 124. And that's a lot quicker if you spot that trick. The trick that I've just used is effectively called a telescoping sum, or the method of differences. So a telescoping sum is where you have lots and lots of terms added together. Some are positive, some are negative, most of which will end up cancelling out, but like we just had some cancel out, leaving over only a few terms left, which is much easier to calculate. Now notice this is why it's called a telescoping sum, because the sum is said to collapse like a telescope would if you was to close. You imagine closing a telescope and suddenly it's very short compared to how long it was previously, and that's the collapsing of that is the idea of the telescoping sum. So this is actually the example we just looked at. The 2 cubes cancel, the 3 cubes cancel, the 4 cubes cancel, and we already saw that this was equal to 124. But this one is slightly differently. Minus a half. Oh no, sorry, it's very similar actually. You've got minus a half and then plus a half, minus a third, plus a third, minus a quarter, plus a quarter, minus a fifth, plus a fifth. So they all cancel out. The only things left, and very often it's the first or the second terms left. 1 over 1 is 1, minus a sixth. That's still left as well. And so this one is simply equal to 5 over 6. The third one, let's have a look at this one. Well, I've got minus a third, alright, minus a third, but then it says plus a third, so they cancel that. So you should get your head around this now. Now the half doesn't cancel, but minus a quarter does, plus a quarter. Minus a fifth does, minus a sixth does, and there's no seventh. There's no. So actually on this one I've got 4 terms left, I think. So I've got 1 over 1, which is 1. I've got plus a half. I've got this still left, minus a seventh, minus an eighth at the end. So if we put them all over 8, I get 8 over 8 plus 4 over 8. Oh, I've got to put them over 56. I'm being stupid here. 8 and 7 go into 56. I could just type them into my calculator, but where's the fun of that? So 56 over 56. I've got half there, for that's 28 over 56, minus 8 over 56, minus 7 over 56. And presumably all of you guys have done this here already. That's 30, 84, minus 15 sounds to me to be 69 over 56, but who knows, you'll probably tell me I've got it wrong. So this then is called a method of differences. We find it by essentially doing lots of subtractions. It's the subtractions that make this possible. So that's why it's called a method of differences. And sometimes the expression doesn't have a difference in it, a subtraction. So you have to make one somehow, and then you can do the sum. So if I show you an example of that in action, now notice this is really what I'm after. I want to add up all these terms from 1 up to n of 1 over r plus n, r plus 1, sorry. But of course there's no subtraction in here. Now, quite often in a question, they'll tell you what the subtraction has to be. And notice it says verify that 1 over r minus 1 over r plus 1 is equal. And this, of course, is equal to the thing that we've got here. So let's just do the maths, the bit of algebra that they want me to do. It's just a case of adding fractions together, algebraic fractions. It's GCSE really. Now, obviously they've got different denominators, so I have to put them all over the same denominator. And I'm just multiplying the two denominators together. And r has been times by r plus 1, so 1 is times by r plus 1, so there you go. And the r plus 1 is times by r, so 1 is times by r. And that then gives me, and now I can put, they're the same denominator, it's r plus 1 minus r. Well, that's only 1 left because the r's cancel. Of course, over r plus 1. So on part 2 then, it says it wants me to find the sum of all these terms, 1 over r plus 1. Or going from r equals 1 to n. And the trick is to go, hang on a bit, I know what this is. It's equal to this thing up here. So I'm going to write, well, that's the same thing as the sum from r equals 1 to n of, what do I do? Well, it's 1 over r minus 1 over r plus 1. That's what I need to do. So I'm going to list out these terms. The first term, when r is 1, so I'm going to write here r equals 1. The first term would be 1 over 1, notice r is 1, minus 1 over 2, because 1 plus 1 is 2. That's my first term when r is 1. And I'm going to add to it what I get when r is 2. Well, put 2 in, I get 1 over 2 minus 1 over 3. Plus, and I reckon when r is 3, I'll get 1 over 3 minus 1 over 4. And you start to spot a pattern. And the problem is, this is only the start of the sequence, but I'm already seeing that that will cancel with that, and that will cancel with that, and presumably that will cancel with whatever comes next. Now we have to do the other end of this sequence as well, so I'm going to do r equal n minus 2, that's an equals. I'll do r equals n minus 1, and my last term will say r equals n. So what will it equal when I do this? So I'll go dot 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 plus, well, I would actually find it easier to start this one, because, and the reason I start with that one, because it's dead easy to put r is n into my expression. I get 1 over n minus 1 over n plus 1. Told you it was easy. Exactly the same as that. But when I put n minus 1 in, I get 1 over n minus 1. N minus 1 goes into that. N minus 1 plus 1, minus 1 over n, that's right. And this one, if I put n minus 2 in, it'll be 1 over n minus 2 minus 1 over minus 2 plus 1 is n minus 1. And what you'll notice is that plus cancels with that, and that cancels with that. My guess was that will cancel with that. And overall, I'm left with only two terms, a bit like we were doing before. It's 1 over 1 minus this thing, 1 over n plus 1. Now, I can tidy that up. It's obviously 1 over that, like that. And I could even put that over a common denominator of n plus 1 minus 1 over n plus 1, which is n over n plus 1. Although you can leave it either way, really. Depends what they wanted. Oh, I did both ways. So make sure you get your head around that. Here's another example. So here, again, it starts off with a verify. This minus this equals this. Okay, let's do the verify bit. I've got to do 2r plus 1 cubed minus 2r minus 1 cubed. Now, just very quickly, I don't really want to do it. I'm just going to write it down. There you go. So, as I say, I just quickly wrote this down. So, obviously, 2r plus 1 gives me that, and this gives me this. And if I just tidy it up now, it should now work. So I get 8r cubed plus 8r squared plus 2r plus another 4r squared plus another 4r plus a 1. And that's just this first term. And if I just tidy that up, I'm going to write 8r cubed plus 12r squared plus 6r plus 1. And the great thing is I therefore know, because this is almost identical, I mean I should be able to say this is going to also give me 8r cubed. Just write it here. I reckon it will give me a minus 12r squared. It will go plus minus. So plus a 6r minus a 1. And you can check that. And this then gives me, well, the 8r cubes go. I've got 12r squared minus a minus, so that gives me 24r squared. The 6r's cancel, plus 2. So I've proven, with a bit of a you doing that for me as well, that verification works. I'm going to erase all of that annotations, because I now want to do part 2. And I effectively now know that 24r squared is plus 2 is equal to this. But just bear that in mind. So essentially it'd be quite easy for me to say the script that I can say, well, that can be written as this. Obviously this sum from r equals 1 to n, r equals 1 to n, and it can be now written in the backward version, the original version I got. So that was 2r plus 1 cubed minus 2r minus 1 cubed. And what's that give me? That gives me an ability to use that now to solve this method of differences. And obviously the way to do it is to, well, I'm going to attack this right hand side again. I'm going to say, oops, I've just lost my pen for some reason. What's going on here? That's better. So let's go back to my pen. So what I'm going to do is I'm going to chuck r equal 1 in. Which put 1 in, I get 2 plus 1 is 3. So that is 3 cubed. That's right. Minus, if I put 1 into this one, I get 2 minus 1, which is 1 cubed. I'm going to add to it. When r is 2, I will get 2 goes 4 plus 1 cubed, so it's 5 cubed minus 3 cubed. I think that's right. 4 minus 1 here. So you can see what's happening. These are cancelling. R equals 3 will give me 3, that's 7 cubed minus 5 cubed. And again the 5 cubed will cancel, then the 7 cubed I'm guessing will cancel. And you can see I'm left with effectively just that. At the other end, so I'm going to write plus the other end as well. When r is n minus 2, when r is n minus 1, and r is n, well, obviously the n one is easy. This one is 2n plus 1 cubed minus 2n minus 1 cubed. But what about here when it's r is n minus 1? I've got to do 2 lots of n minus 1, which is 2n minus 2, and therefore it's 2n minus 1 cubed minus, if I put n minus 1, I get 2n minus 2, 2n minus 3. And yeah, it's all working out fine, this. I'm not sure I need to do that one, so that one will cancel with that one. I reckon that one will cancel with one over here, and I reckon I'm left with that. And on this side, therefore, I'm left with, I think I get a 2n plus 1 cubed minus 1 cubed. Now just bear in mind, that's the right hand side of this expression. On the left hand side of this expression, I've got 24r squared. So that's 24 times by, I'm going to run out of time on this. I've got 24 times by the r squared, so sigma r squared. Plus, now we already know that when you add up all the 2's from 1 to n, you'll get 2n. So it allows me to write over here, I've got 24 sigma r squared plus 2n equals this expression. And therefore 24 sigma r squared is going to equal the 2n plus 1 cubed minus 1 cubed, well, call that 1, minus the 2n from over here. And my job obviously will be to carry this on in another video, so I'll finish this off in another video. So expect a second video.